Hello everybody. I am pleased today to talk about the theme expansive clay. This presentation was given as a conference keynote lecture during the 4th Scientific Conference on Geosciences and Environmental Management in Salé, Morocco. The title is Expansive Clays, Is It a Hidden Problem in Civil Engineering? The content of this presentation: first, an introduction about expansive soils, their location, which soils are expansive, and their typical behavior and occasional damages. Then we go through the characterization of expansive soils, how to proceed, then the measurement of the swelling pressure and shortcomings, if any. Then we will present a new method to characterize expansive soils. In the third section, we will talk about the mitigation of the swelling phenomena, experience and method, do some critical review, and the proposed method, and finally conclusion and future investigations. As introduction, this slide we see the location of expansive soils. As we can see on the world map, expansive soils is widespread geological hazards. All the black zones, areas, correspond to the existence of expansive soils, as we can see in Africa, Asia, Europe, Oceania, North and South Americas. And specifically, we found expansive soils in arid or semi-arid climate. Specifically in the North Africa, we also have expansive soils. What is an expansive soil? Referring to this figure, courtesy by BRGM 2010, expansive soil are typically clays, and they exhibit volume change due to the variation of water content over seasons. We have cycles of shrink and swell behavior. And importantly, the smectite group and the montmorillonite type of clay is a good example of an expansive soil. So the volume change or volume variation, it can happen first by evapotranspiration from the trees to the air. By evaporation, the water at the ground surface evaporates in the air. And third, water absorption within the ground, for example, by the roots of trees. So there are three possibilities to have this volume change. The damages and occasional costs. We have chosen two case studies. The first in Morocco. The first case study is School A in Meknes, and the second is the Hospital of Moulay Ismail. And for this Moroccan case study, we can observe wall and roof cracks. And the second example comes from Tunisia, in Tunis, at the National Engineering School of Tunis. We can see also cracks in the walls and several directions. And so the damage costs a lot, as we can see on the next slide. So due to these damages, we have extra cost, which is greater than 8,000 million US dollar per year. And we also have a loss of investment due to reduction in the lifetime of affected structures. And in the table, we can see that depending on the country, the extra cost per year is varying in a wide range. For example, Sudan, 6 million US dollar. United States, depending 3 authors, this cost is very high, so it can vary from 6 billion to 15 billion US dollar. UK and Saudi Arabia, this cost is varying between 300 million US dollar to 450 million US dollar. While in China, it is about 1 billion US dollar. So, to talk about the characterization of expansive soils and how to proceed, we can ask this question: is there a universal method to characterize expansive soils? The current method, we can consider 2 types of method after Sridharan and Prakash. First is the mineralogical identification, and second is the inferential testing. About the mineralogical identification method, so we have different tools. For example, X-ray diffraction analysis, differential thermal, the blue material value, chemical analysis, and scanning electronic microscopy. But what are the disadvantages of this type of methods? They are expensive and restricted for use. Why? Because we can use these methods only in research laboratories. So there is no determination of the swelling pressure. They need sophisticated equipment, and also they need an expert's interpretation. Coming to the inferential testing method. So this type of methods, first, we need to estimate the swell potential and volume variation. So we have the involved index properties of the expansive soil, Atterberg limits, shrinkage limit, shrinkage index, and the clay fraction. For the volume variation, so we can do the free swell test or expansive percentage in Oedometer test. Whilst for the swelling pressure determination, we can use one of the 3 standards, ASTM, US, XP, France, and IS Indian standard, using the Oedometer equipment. The measurement of the swelling pressure, and what about the current practice? So, considering the 3 standards we introduced, the one of ASTM uses the swell load method, and by definition the swelling pressure is equal to the minimum stress required to prevent swelling. For the Indian standard, the constant volume method, the swelling pressure is the pressure exhibited by the expansive soil if the soil is not allowed to swell or the volume change of the soil is neutralized. And third, using the French standard, the swell under load method, the swelling pressure is the stress to apply to the swelling soil, so that when brought into contact with water at atmospheric pressure, the corresponding axial deformation is 0. Let us illustrate the 3 methods by this typical diagram, the change in volume versus the pressure to determine the swelling pressure. So, for example, for the STM standard, so we need to apply different stresses to neutralize the axial deformation, and it is the stress value correspond to 0 change in volume or axial deformation. In Oedometer condition it's the same. For the Indian standard, we try to neutralize the volume variation near 0, and the value of the stress will be this one to have the swelling pressure. About the French standard, we will illustrate in details. So we need to perform at least 4 tests or even 5 tests on different specimens, and for different stresses we will determine when the axial deformation becomes 0, and here we determine the swelling pressure. Compared to existing data, the French standard usually overestimates the swelling pressure. A new point of view about the swelling pressure, because when we come back to the structure of saturated expansive soil, so here we have the particles and water in case of full saturation. But if we go through the details of particles, we know that the particles are composed by clay aggregates, and we have some chemical liaison between them. So the increase in volume when we have water infiltration between the clay aggregates or inside the clay aggregates, this corresponds to the swelling phenomena. So the swelling pressure is a local value that exists inside a clay particle between lattice layer, and this is of course somehow different, for example, when we talk about the water pressure between the particles. We will show some examples to measure the swelling pressure. Here we have a Tunisian case study of an expansive soil from Gafsa city, and the geotechnical report, as we can see here, we tested 3 intact samples at different depths, and it is written the swelling pressure is 0. However, after some classification we will go through, and considering the value of the liquid limit and the plasticity index, the swelling pressure is not equal to 0. Let us say it is not a good example to measure the swelling pressure, because we know that this type of soil is a swelling soil, but still we need, or we put swelling pressure is 0. About the characterization of expansive soil, the answer to the question initially asked, is there a universal method to characterize expansive soil? The reply is no, there is not. Simply because, for example, we consider the classification based on liquid limit after several authors. We can see for each author suggests the swell potential, the degree of swell potential, low, medium, high, and very high, and different ranges of the liquid limit, and the same when considering the plasticity index. So what we can say here, that these tables show different range of the liquid limit and the plasticity index for the same degree of the swelling or the swell potential. For example, based on the Andean standard, we can have a medium or marginal swell potential because the liquid limit is in this range. But this range overall fits in this one, and after Chen is not a marginal swell potential, it is rather a high swell potential. This is why we don't have a universal method to characterize expansive soils. As we introduced first, the Oedometer test is the most used to characterize expansive soils in general. So from the Oedometer test, we can measure the compression index, the swelling index, and the swelling pressure. So this is a typical curve from the Oedometer test showing in the first stage the increase of the void ratio when the soil is saturated, and this is the swelling phase. And then when we load the specimen, of course the void ratio decreases, and then we have the consolidation phase. And then during the unloading, we will have again the increase of the void ratio. So that means we can use the compression index, this slope, and the swelling index, the slope, and the value of the swelling pressure. Consider now some typical Oedometer curves of Tunisian clays. Here we have the reconstituted Tunis soft clay, that is soft soil, and after several tests, the relation between the compression index and the swelling index is about 10. For example, here CC is 0.63 and CS is 0.064. Another example of Tunisian clay from matter is different from this one, and we have roughly the same ratio between the compression index and the swelling index. Considering some case study in Tunisia, Institute for Preparing Engineering Study at the University of Tunis in Manar. So in this area, we experienced expansive clay from several case studies. And here we have the log of a borehole executed in this project. As we can see here, the shear strength of the soil is or correspond to a stiff clay. That means good strength resistance. But when considering the Oedometer curves of this soil for loading and unloading, what we can see? We can see that the compression index is about 2.9, the swelling index value, as we can see here. So the two slopes are as represented. For another example, at a different depth, this ratio is about 3. And the swelling pressure after the ASTM method is about 19 kPa. And if we now compare the two examples of the silk clay at Mater in Tunisia, for which the compression index is about 9.9, the swelling index, and this one for which the compression index is about 2.9, the swelling index, and swelling pressure is high, 200 kPa. So now we can say, is the CC by CS ratio is a good indicator to characterize an expansive soil. And the matter of fact that during a PhD work, prepared by fellow Sergio Maninievi that I supervising. We considered the characterization of expansive soil using the CC by CS ratio, and we collected 52 Oedometer test results with the values of the compression and swelling indices and the swelling pressure value, and all samples were clay. And this table shows that 40 samples come from Tunisia, 8 from Algeria, and 4 from Morocco. And considering the Tunisian data, only 24 samples are expansive soil, while 16 are not. And in total, between Algeria and Morocco, we have 12 exactly samples. And now let us see in this chart that represent the swelling pressure as a function of the CC by CS ratio. And as we can see here in red, the Tunisian non-expansive clays, and in blue the Tunisian expansive clays, in green the Algerian expansive samples, and here the 4 Moroccan expansive samples. Okay, what we can see here, for about CC by CS equal 10, we consider that there is separation between the non-expansive clays and expansive clays, and the value of swelling pressure equal 15 kPa is the limit to have rather an expansive clay or a non-expansive clay. In a different way, we can also represent the compression index as a function of the swelling index. And we can see here that we can consider 3 zones. Zone 1, for which the compression index by the swelling index is higher than 10, and we have from the left side zone 3 when the CC by CS is more than 15, and here is less than 10, and we have an intermediate zone. So we can say that the swelling pressure, when it is greater than 50 kPa, we have an expansive soil, and we can consider in the range 0 to 50 kPa this zone, and the third one is the one for which really the swelling pressure is 0. So the new method you are introducing, how we can discuss the results. If you have an expansive soils, usually the CC by CS ratio is greater or equal 15, and almost the swelling pressure is 0. But we can have low swelling potential as reported by Chen and Codito when the swelling pressure is less than 50 kPa. And as we can see in this table, so we have an expansive soil when CC by CS is less than 10 and the sigma S, the swelling pressure, is higher than 50 kPa. We can say we have a non-expansive soil when the CC by CS is greater than 10 and the swelling pressure is less than 50, and the soil is non-expansive when the ratio CC by CS is over 15 and the swelling pressure is 0. Coming now to the mitigation of the swelling phenomena, there are some existing improvements. So some author suggest the use of pile, granular pile or helical piles. Or also we can consider chemical treatments with added cement, lime or salt and some combination. And the soil mixture is also the use of core geotic style treatment, or even the replacement of the soil and the use of strong inner structure or the structure isolation from the swelling clay. So we have different methods of mitigation to avoid the swelling phenomena and to avoid the damages we talk about. So mitigation of the swelling phenomenon, the use of pile, for example, we can reduce the swelling pressure about 10 to 40% after K1990 when using the helical piles. Length of pile and over the thickness of the swelling soil is about 3.2. Okay, we can reduce the lateral movement about 70% and the vertical movement about 95%, and these are some indication. The mitigation using the chemical treatment after work by Mohammadi and Kamisa from Algeria. So we can use, for example, lime treatment, cement treatment, and some recommended percentage, for example here 10% of cement, and weak swelling potential. We have a reduction of the liquid limit and the plasticity index of about 41%. For the lime treatment, we have mostly the same ratio of reduction of the WL and PI. Chemical treatment, we also have some formulation, and we can reduce the swelling potential at a different rate. What we suggested recently after this work, when we have a foundation to be built on expansive soils, the idea is to execute a granular material over some thickness. And what is the benefit when the expansive soil is saturated? So the pressure or the swelling pressure will be somehow reduced to by the infiltration of water here, and so that the swelling pressure is not fully applied when it is in the contact with the foundation. And the matter of fact that we have performed an Oedometer test for which the specimen comprises two materials, as we can see here. We have the thickness of the granular materials, HJ, and the thickness of the expansive soil. And from the Oedometer test, we recorded the reduction of the upward displacement by 21%. So that means we are suggesting here a simple method to use a compacted granular material as an interface between the foundation and the expansive soil. As a conclusion, expansive soils is a worldwide problematic soil category in the construction field in general. So it have the disadvantage a high cost for repairing and the maintenance. After about 50 collected data from the Maghreb, Tunisia, Algeria, and Morocco, we showed that the CC by CS ratio is a good indicator for expansive soil characterization. And the main result here, that when this ratio is over 10 and the swelling pressure is less than 50, is a moderate or marginal swelling soil. When the CC by CS ratio, we need to determine the swelling pressure, and the soil is of course classified as expansive. And for sure, when the CC by CS is greater or equal to 15, almost the swelling pressure is zero, and the use of granular material as an interface may reduce the upward displacement. as forthcoming development. So we need to collect a lot of data to confirm the characterization method we suggested. We also need to use a precise determination of the degree of swell potential or the prediction of the swelling pressure, and to confirm that the use of granular materials, we need to optimize the thickness of granular material layer that we can place as an interface between the expansive soil and the foundation. Thank you very much for listening.